Hi guys, welcome to another video on linear algebra. In this video we'll continue looking at systems of linear equations in more than two variables. Here we have the objectives for this video. Let's proceed. Now if you recall from the previous video, given a system of equation looking like this, we would find the augmented matrix, after which we would write it in row echelon form, and we'll be able to obtain the solution to be x is equal to 3, y is equal to 2, and z is equal to 1. Now this is a unique solution because it's the only solution that will work for all three equations in our system. Now it is possible for us to have a solution that can work for one, but it will not work for all three. Now this here is the only one that will do so, and that's why in this case we have a unique solution. So once you're able to solve the system and get a solution like this, so one value for x, one value for y, one value for z, then this is a unique solution. It is also possible for a system to have no solution. So let's consider the system. We know we start by writing the augmented matrix, and we then write this as in row echelon form. Now give me a second. Now, so we left off our line. Now I would suggest that you pause the video and try to write this matrix here in this form. So try to obtain this form. Now we can get our equations. So we know that we could say 1x plus 4z is equal to 1. But that's not the important part here. I want to focus on the last row. I want to focus on this row, where 0x plus 0y plus 0z is equal to negative 3. Now basically what this is telling us is that 0 is equal to negative 3. Now that doesn't seem very logical to me, right? It is impossible for 0 to be equal to negative 3, and hence in this case we have no solution. Now once you have something like this, it is a clear indication that this system does not have a solution. However, what I would like for you to do is just to verify. So if you end up with this, you just double check to ensure that you didn't make any error, everything is fine, and then if that's the case, you see there is no solution. Now it is possible as well for us to have infinitely many solutions. So we consider this system of equation. We know to find this, to solve this, we need to do the augmented matrix. Now usually, just a note, usually we have infinitely many solutions whenever we have more variables than equations. So our augmented matrix will look something like that, and then writing it in row echelon form, we would end up with something like this. Now our equations that we can derive would be x minus 7z is equal to negative 5, and y minus 3z is equal to 1. Now our free variable z, we just call that t. So we use the parameter t, and t is in R, so t is just some real number. So we can rewrite x and y in terms of z. Now what this is saying is that whatever we choose our t to be, t can be any real number, remember, we can find a corresponding value for y and a corresponding value for x, and this would form a solution for our system. So if I take t to be equal to 3, then it would mean that x is equal to 16, y is equal to 10, and of course z, which is equal to t, is equal to 3. We don't need this t in r here. Now you can go ahead, plug this in the system, and you realize that it holds true for all the equations in the system. What I want you to do though is try another value for t. I mean, mix it up, have fun. Go ahead, use a decimal, use a negative number. So try another value for t, and you'll realize that, hey, the, the corresponding value for x, y, and z, they work, and so we can find infinitely many solutions. Because remember, t is just a real number, and since it works for all values of t, we can have infinitely many solutions. We now turn our attention to homogeneous equations. Now, here we have a homogeneous equation. Now, this homogeneous equation, the homogeneous equation is always equal to 0. Right? Now, we start similarly. We use the coefficients and we get our matrix. Now, our aim is to get it to look something like a reduced, well, like a row in row echelon form. So we want this to be 0, we want this to be 0. And remember, with the row operations, so we know that 1 minus 1 is equal to 0. So it means that we can subtract for row 3, sorry, for row 2, it is row 2 minus row 1. Because when we subtract this here from this, we would get 0. Now this 4 here, we want it to be 0. So that's definitely 4 minus 4, right? So it would be row 3 would be equal to row 3. So this, to get this to be 4, we just need to multiply by 4. Minus 4 row 1. Alright? So doing that would give us something looking like that. Now, ideally, we would want this to be 1, but because, I mean, we have a negative 1 here, if I divide this by 2, then I will have a negative half, and I really don't want to work with the fractions now. So I will just leave that 2 as is. Now I want this here to be 0, so all I need to do is to just subtract row 2 from row 3. Now we can derive our equations and then we can simplify after. So the first equation, x minus x1 sorry minus x2 minus x3 plus 3x4 is equal to 0. 2x2 minus x3 minus 2x4. So we're just using these values here and the corresponding x's. So that's x1, that's x2, x3, x4. That doesn't look very x-ish. Okay, x4. Right? And similarly, we can get 9x3 minus 9x4 is equal to 0. Now, quick question. We have 4 variables, x1, x2, x3, and we have 3 equations. What did I say earlier? I know you got it. Now, when that means that we're going to have some infinitely many solution type of thing happening here, right? So, what would be our free variable? So, x1 is caught up here, x2, x3, so x4 is what's left. So, x4 will be our free variable. So, we let x4 be equal to t. So if x4 is equal to t, x3 will also be equal to t. And why is that so? Now, if we look at this equation here, 9x3 minus 9x4, if we solve that, we realize that x3 is equal to x4, and x4 is t, so x3 is t. Now x2 is equal to, so from here, making x2 the subject, we get t divided by 2 plus a half, which is just, plus t, sorry, which is just 3 halves t. So this isn't 3 over 2t, this is basically 3t over 2. Alright? And x1, do you think you could pause the video and do x1? Of course you can. Now x1 is just negative half t. So once again, this is just negative half t, or we can look at it as negative t over 2, whichever is fine. And remember that t is a real number, so t is in R. So that would be our solution for our homogeneous equation.